Okay, so I'm on. I do apologize for the delay. Partially on my side, partially on the internet side. Well, the internet's caused me to be delayed. So what I'm going to do in the next couple of minutes is I'm going to send you out work. But want to have a chat before I just kind of leave you to it. I want to kind of talk to you guys for a bit today, see how people are doing in terms of what we're up to before we do any of that. Because I've set a lot of work, and I'm getting a lot back. To be fair, there's a lot of you guys doing the right thing. But I want to get an idea of how much are we actually understanding and what do we need help with. Good morning, Rashida. Good morning. So before I hand out the next set of work, I want to hear feedback in the live chat about how's it going so far in terms of your learning. What would you like me to spend some more time on? All right. And of course, there is work for today. I'll send that out momentarily. But yes, the question I'm asking you right now is, so far, what do you need support with? Okay, and then what we'll do after that, hey, good to see you, Ziza. And after that, obviously, we can start doing the next thing. On Monday, we'll do another one of the group chats. Definitely, because I thought that worked really quite well. Okie dokie. Really struggled on it because I didn't see it yet. Fair shout. It's going to be difficult otherwise. I mean, that's why we do the live streams. If I just leave you with work, it's not fair, is it? So you struggle a lot with mechanics. So I'm just looking on the scheme of work now. Mechanics is a couple of weeks down the line. It's in the 18th of May. So it's the last week before half term. So what I can do is spend a whole week on it. Stats we're going to start covering in the 11th of May. So right now we're just doing all of the pure stuff. But yeah, we'll definitely cover that. So mechanics will get. Do you know what I'll do? I'll say I might change up the scheme of work a teensy bit and go 1 week for stats, 1 week for mechanics. You can have a whole week doing this stuff. All right. So yeah, so definitely binomials coming. So if you look on your scheme of work, 11th of May that week will be the stats week then, and then 18th of May. Good to see both of you guys. 18th of May will be the mechanics week. What else do we not happy with? I mean, in the pure content, because the next topic you've got today is coordinate geometry. And I'm going to send that to you now, and we can do the general thing about, okay, let's just have a chat about it. Let's see where you need help on But what in pure is especially bad? That would be a useful conversation to have. Like, what do people want to see? I'm going to send out your work now. So it looks like a lot of the stuff you're asking for is something that I've already planned to do. That's comfy. It's just later on in the term, on this half term. After half term, I'm sure you know, well, I hope you know anyways, that what we're going to be covering is second year content and doing a project and stuff like that. So it's going to be, this half term is the term to finish this year's work. All right. So year one is done. I mean, to be fair, it's done already, but I mean, done, as in like you fully understand it by the end of this half term. I mean, in terms of content, we should have covered it all really, but right, anyways, coordinate geometry this time. Okie dokes. So let's have a little look at that. I'm sending it out now. Well, should be sending it out now. Put this up. I'm having all kinds of fun with my Wi-Fi. That's why everything's delayed today. If anyone was curious, like why everything's like 5 or 10 minutes late, which it is. It's my Wi-Fi went down, and you can like to be fair, I could have sent the email by a kind of data, but if I started streaming on data, I wouldn't have any data left. So today's work. So let's have a look at this then. Right, I've sent it out. So if you pop up to your emails, that should now be out for you. Not that. Why have you shown me that? I'm not interested. So check your emails and pop up in the chat and tell me whether you've got the thing or not. Let me have a look, see what you're saying. Vectors, yeah, vectors. When am I doing vectors? 4th of May, so that's next lesson. Yeah, it says vectors and the binomial expansion, but we'll start with vectors first. All right, and then we'll have good. If it goes the whole lesson, then it goes the whole lesson. It is what it is. I'll just make an extra video for binomial expansion. So if I ever have to make an extra video, that will be one that I'm not live streaming. It'll be just one that you can just go and watch at your own time. Because I reckon binomial expansion, I mean, we'll see. If it's something that we're struggling on both of them, we'll do that. Hardy, good to see you. Sir, I sent solutions. Oh, go me. What an idiot. Let me send you the... Well, at least that saves me sending those later. Let's have a look. Lovely. Oh, I've made a mess of everything. Ugh. Not having a good day today, as you can imagine. Where have I sent it? Last lessons. What was the last thing I sent? Okay, cool. So you've got the solutions early. Lovely. Did I really? I'm looking at this and it just says coordinate geometry. I don't think there's solutions on that. I'm sorry. I think you were wrong, sir. What I've literally just sent out should just be the coordinate geometry stuff. So, no, I take that back. I think I've done that right. I need something to wipe the table down there. You can't see it, but I literally got a bottle. Ugh, never mind. You can't see it. Doesn't matter. It doesn't exist. Right, cool. Nobody got solutions. You got solutions with yours. Yeah, but probably not for the right thing. If you did, happy days. I'm not bothered, right? I mean, you're going to get the solutions anyways. And those who didn't get solutions, don't stress, right? I'm going to email you solutions at the end of this lesson, all right? So if you open up the coordinate geometry stuff, let's have a chat about that. I'm just going to scroll back through the chat to see who raised other topics in Pure that they weren't happy with. The last one I saw was Rashida's vectors. So yeah, so those guys are just popping in. What the question I asked, the question I just rubbed off is, we're basically going to finish the recap of Pure next Thursday, right? So you've got maybe 3 more lessons. And I want to know, where's your weak points of Pure? And what you'd like me to cover, because some of them are like options. Like I can do vectors or the binomial expansion. And you saw this week that I chose to do trigonometry over polynomials. For obvious reasons, that's the trigonometry comes up more. All right, cool. So pop that up in the chat, what you want to see. And then after that, have a look at the work that I've sent you, and we'll start having a little discussion on that, see what you've been asked of me today. Is question 2 a worded answer question? Let's have a look. I'll find out for you. The early ones generally aren't, but coordinate geometry, there we go. I need to keep that in the picture. Keep that in the picture. Brilliant. Okay, describe fully. No, it's not an essay question. It's something that's got a very, very obvious answer. Does anyone want to help Rashida out? If you look at question 2, what is the very, very kind of like thing you should know? You just have to look at that and go, that's anyone want to bail her out on that one? So I'm just checking through the chats. Of course it is a circle. What's the radius? So what's the radius? There's your second mark, by the way. Right, so Dowitz, I'm just going through the chats at the moment. Dowitz were doing difference of 2 squares. No, it'd be a minus sign. And even then, it's not difference of 2 squares. It's another shape. I think it's a hyperbola. But do you know what? You don't need to know that. Yeah, radius 2. To be a difference of 2 squares, no disrespect to you, Dowit, it has to be a difference. Right, Dowit's work, good. Well done. You've done your work so far. Olivia, I've got all your stuff now. Excellent. These are people in my other class. Khalil is asking silly questions again. Warren, yeah, good stuff. Omo, good. Fazana, good. Ziza, yeah, no worries, no worries. I'm gonna have a little chat with you anyways about some, like, you know, some of the stuff you said in there. So don't worry about that, but I'm happy. Mawson, good. Jacob, good. Kausa, good. Zeron, good. Demetrios, good. Dante, good. Jazir, good. Harley, good. Rashida, I'm still missing work. Abra, good. Can look at question 4, questions out. Yeah, I will. I'll look at all the questions. Just give me a minute. Just I want to go through, like, see who I need to kill. Ishmael, I need to get hold of. Kais, I'm still missing work. Rahat, I'm missing work, and Sabirul. So what I'm going to do is, if you keep missing work, then I'm going to have to contact your parents. So I'm going to ring them up using, like, withheld number. Really, this class, I think, has been outstanding so far in their work. But if I keep having to type that message, and there is a couple of you that are in here that I have to keep typing that message, work not in by time, then I'm sorry, but, you know, this is a pain for me, doing all this stuff. And I want the effort to be there. But I will say the vast majority of people are getting in their work. It might be like, you know, a couple of hours late, you know, the end of the world. That's not the end of the world, right? Do your best. And I mean, people are struggling with rubbish internet and they're still managing to get their work in. I'm super happy with this class. Don't get it twisted. But, like, there are a couple of you that are taking the mickey, or a couple of you just not taking it seriously. Please take it deadly seriously, right? Okay? Because at the end of the day, I have to look through every single lesson. I have to look through people's work and see if it's right. I need to see whether it's been marked, all that stuff. Otherwise, I've got no idea of understanding of where you are in your learning. All right? Okay, let's roll anyways. Okay, cool. So questions were asked were 4 and 7. Let's roll. Let us roll. So I've just opened it up. Show that something's a tangent to. Dante, I did not see any work sent at once. Right, you check your emails, Dante. Cool. So I don't think he's on. He must have dropped out of the YouTube thingy. So cool. So question 4. Let's start with some definitions. Go away, thank you. Show that something is a tangent to. So the word tangent implies what? If two things are one's a tangent to another thing. If one thing's a tangent to another thing, what can we say about them? A tangent tells me what? I need to turn off Microsoft Teams on my computer, so it's literally going to pop up through this whole this video otherwise. Because some of you guys are talking to me through the chat, and that's fair enough. I don't mind. That's good. But, you know. Right, did I not turn this off? Go away. Close window. Okay. I said close, Daniel. Right. Okay, cool. So touching, yeah. That's one thing. Good stuff, Rashida. Well played. There's something else more important, right? Not to criticize what you said, which was right. There's nothing wrong with that. But there's something else you can say if something's a tangent to something else. The gradient of curves is a grid, yeah. So gradients are the same, yeah? And that's where you need to go with this, yeah? So if I want to show that something is a tangent to something else at a particular point, which I believe is what the question is saying, so I'm just going to bring that back up. Fine. You know what? Anything that could go wrong today has gone wrong today. I'm going to end up starting swearing live on YouTube, and that's not going to be a look. Right, so I'm going to show that this is a tangent to that, all right? So what I'm going to do there, in fact, that's actually got nothing to do with the other one. We need one more thing. We need one more fact. Tangents and circles. Can anyone tell me something about tangents and circles? Good to see you guys. Touches the circumference once. Well, that's what definition of a tangent. But what else does the tangent do that's special? So a tangent to a circle has got, there's something it does to something else of the circle. Does anyone remember it? I'm going to move the camera just a teensy bit. So tangent to a circle, it touches the circle once, and what else does it touch? It touches the circle, touches the circumference of the circle, that's right. But it touches something else. Think back to your GCSE. Really not my day today. I'm in a silence on this. I'm going to give you a few seconds, see if you remember. Go back to your circle, literally go back to your circle theory. It's that simple. A tangent, nope. A tangent circle is perpendicular to its radius. Yeah, perpendicular to it. I'm going to draw you a picture to show you this. It's got nothing to do with the X or Y axis, I'm sorry to say, Rashida, but good guess anyways, right? So let me draw you a picture. So imagine you had a circle, right? Boom, there's your tangent, right? If you drew a radius to the same point where the tangent touches the circle. That and that are perpendicular to each other. So the radius and the tangent, I'm going to blow up Microsoft Teams in a minute, seriously. Allow me before I start cussing out on the live on the Insta. It's not your fault. It's just some rant. Like, everyone in the world wants to talk to me today. And it's like, I don't mind talking to you. It's the other people I'll find annoying. Anyways, leave it. So if you've got a tangent touches the circle at one point, radius touches the tangent. Where the radius and tangent meet, that's a 90-degree angle. So the radius at the point and the tangent at the point are perpendicular. What do we know about perpendicular gradients? If two gradients are perpendicular, what can we say about them? So we've got this as a 90-degree one. So radius and a tangent meet at 90 degrees. Great. But what does that mean in terms of gradients now? What can we say? Pop in the chat box. Yeah, negative reciprocal, yeah? Negative reciprocal. So if you know the gradient of the radius, you know the gradient of the tangent and vice versa, right? So let's have a go at this. Okay. We're going to do this question now together. Can everyone have written down the notes of the facts I'm going to use? Because now when I'm going to do my working out, I'm going to just use those facts. I'm going to say, this is when you use this fact, all right? Let's bang it out now. Question 4. Show that the line y equals 3x minus 10 is a tangent to the circle x squared plus y squared equals 10. All right, cool. So we know that this guy's got center of 0, 0, radius of root 10. Not that I particularly care about the magnitude of the radius, but it's there. Okay, cool. Is a tangent to the circle. We've got to first of all show where they meet then. If we're going to show it's a tangent, it should meet at only one place. So therefore, I'm going to solve this equation simultaneously. So what you're going to get is 3x squared plus 3x minus 10 squared equals 10. Now, why am I doing that? I'm going to solve that equation, find what x and y are, and that x and y that I get from this, and you're going to do this in a minute for me, that x and y that you're going to find out of that situation is the coordinate where 3x, y equals 3x minus 10 touches the circle, right? So I hope that makes sense to you. Now, you can say to me, VJ, actually, you can cut out a lot of pain here. You can make this very, very simple for yourself. And I've just thought of this myself. If you can show that this equation here only has one solution for x, you only have one solution for y, that means it's only going to touch the curve in one place, and a line that only touches a curve in one place, by definition, is a tangent, right? Does that make sense? So that's all you have to do. You don't have to faff around with the gradient either. I've just thought of that. It's just so much better. So what we're going to do is we're going to do these as simultaneous equations, find out how many times they meet. And if they only meet once, then by definition, this is a tangent of that, yeah? If you think to yourself, well, what could happen with a circle and a line? There are 3 potential outcomes, right? You could get this, tangent. You could get this, which would give you a chord and a segment, or you could get them completely missing, yeah? If this equation and this equation solved as simultaneous equations, don't worry, Dante, just do your best. If these 2 equations solved as simultaneous equations, right, have only one solution for x and y, that means they only touch in one place. And a line and a curve that only touches in one place, the line is a tangent to the curve, all right? I'm going to ask you guys, can you solve this equation for me? Find out what x and y are, and then we'll move on to question 7. All right, so we're going to do 4 and 7, I think, as a group. That'll be good. Anyone's got any particular problems with that explanation, can you pop up on the live chat for me, yeah? So I want you to try and finish 4 for me. X equals and y equals minus 1. Let's just check that works. If you put it into the first one, you're going to get... Yep, that works. You put the first one, yep. I am willing to go with that. So if you do that for that, you get 9. Yeah. Okay, cool. So that's fine. Cool. I'm a happy person then. Can everyone else check whether they agree? For me, just looking at it by substituting the numbers in, that seems to work. Ah, my life. I'm going to kill everyone in the entire world. Right, good. So that's 4 done. Let's have a crack at 7 then. Sorry, I'm not cursing you out, trust me. Literally nothing that's gone bad today is any one of your fault. It's literally, well, unless you're like Rahat who hasn't come in and I'm going to have to find and fry. But is it fine if you go do the work? Yeah, if you know what you're doing, go ahead, knock yourself out. Okay, cool. So, 7. Bloody hell, there's a lot there, isn't there? Right. 7172, you should be able to do. 73, you should be able to do. 74, you should be able to do. Who asked for 7? Let me hurt them. Right, Rashida. I will help you, but you've got to, on one condition. You've got to explain to me what you actually need help on. All right? Yep. I'm willing, as I said, I'm willing to help you. I'm not going to be too stingy, but I want you to honestly tell me which bit of it you can't do. I'm not going to make fun of you because you couldn't do it. I just want to know. Because to be fair, all the problem with that question is it's long. And that's a fair shout, it is. But long isn't hard necessarily in terms of like mathematics. It just means you have to do loads of sums. So tell me, pick out that you look through 7 for me. Tell me what you can't do there for me. Because I reckon, honest truth, I reckon you could do the whole lot. Maybe not F, but I reckon you could do F as well. Really. All right, fair enough. That's a sensible shot. Let's have a little chat about 7-4 and 7-6. Should I get the equation of SR? Okay, cool. So the question I'm going to ask you is, do you know how to work out the equation of a line? And I'd be surprised if you said no, but okay, suppose you don't. So SR is the line that takes you from 1, 2 to 1 minus 2, sorry, to 9, 2. Yeah? That's how you get from S. That's S to R, right? So what we're going to do is do y equals mx plus c, as you do. Or whatever version of this you do. I mean, like people do y minus y. I don't care. You do your way. I'm not judging. The gradient would be what? 4/8? So half, yeah? So y equals a half x plus c, and then subs in minus 2 and 1. So you get minus 2 equals a half. So you end up minus 2.5, fine. So what'd you get? 2y equals x minus 5? Is that what you're meant to get? Yeah, go me. Okay, cool. So let's just recap what I did there, because I kind of did that in my head without realizing it's something needed to show. What did I do? I said, well, I know it's a straight line, so I'll have that form, right? I'll work out the gradient, which is y2 minus y1. So 2 minus minus 2 is 4, x2 minus x1. Remember that formula for gradient. Again, it's almost, that's what, well, I was surprised you asked for it, because your questions are usually good ones, yeah? Okay, the only thing I could see that would ever give you even the tiniest bit of problems is the bit when, when you're here, you got that right, 5/2, brilliant, yeah? Just times through everything by 2, and you got what you're looking for. 2y equals x minus 5. That's literally the only hard thing you could have there. I'll just move the camera back so you can see that a little better. So that's D done, right? Cool. Happy days. But there's a bit more to do, sorry. It's not quite happy days. We're nearly happy days. Find the equation of L through Q perpendicular to SR. Okay, cool. So we now know that the gradient of this is a half. All right. We want to be perpendicular to SR. So we're going to be y equals, the negative reciprocal of a half is minus 2. So minus 2x plus c. And we know we're going through, what we're going through? R. No, we're going through Q. Q is 6/3. So all you need to do is subs in 6/3. So you go 3 equals minus 12 plus c. C equals 15. Yeah? So y equals minus 2. I don't know if you can see that or not. Y equals minus 2x plus 15. Right? Does that make sense? Do you see, like, sometimes when a teacher does something, it looks super easy. And that's because, like, teachers done the question before, teachers done it for about 1,000 years. This isn't one of those examples. Yeah, this is legitimately one where it is easy, right? And it's fine. I'm glad you asked now rather than you mess it up in the exam. I'm not criticizing you for asking. Let's have a look at F. We'll give F the same treatment, or is F harder? Okay, so you got calculate the area of the quadrilateral. The things you need to know what PQRS is. All right. What quadrilateral is, it would depend, because obviously the area of the quadrilateral depends on which formula you're applying. I would probably, I don't know what it is. Tell you what, I'm going to hang around here for a while. Can you just start on 7? Do 7 for me, at least up to like A and B, and then we'll see if we can figure this out. All right? I'll hang around for, I've got nothing better to do. I'm doing like one-to-ones with my year 13s anyways. So I'll hang around here, right? You do 7, start at 7, right? And I'll walk you through that process. And when you get stuck, stick something on the chat for me, all right? So yeah, today I'm going to hang around here for a little bit longer, all right? So you guys do your work now. Keep the thing running in the background. I'll try not to talk too much, all right? And then if you need help, pop up in a live chat and I'll help you. And while that's all going on, I'll do things like registers and one-to-ones and things like that. Don't worry, okay? So I'll try and keep my mouth shut for now. Okay, all right, so I'm going to hang around here for a bit. You can disappear if you think you don't need any help at all, but I'm going to stay here for a bit, just in case people do need help. All right, let's do this. That's really nice. That's all it is. So again, if anyone needs any help, just pop up. If I find that no one's needing any help, that's comfy. But I did want people to have a chance to, if they need help, they can ask me. I missed it. Right, I don't understand. Okay, cool. It's a quadrilateral log. Yeah, fair shout, it is. Right, let's have a look at it and see what we can do about it. So what we've got there is we've got Can you tell me the gradients? That would be super handy. If you just pop the gradients in the live chat for me, I'll be able to tell you what this is. If you've got two pairs that are the same, then it would either be a rectangle or a square. If you've got one pair that's the same, you've got a trapezium. Not looking for the equation there, Rashida, even though I can read it off if that's what you give me. Yeah, cool. So just give me the gradients, right? Don't even need the x there. Okay, so yeah, beautiful. So I can tell you that it's either a rectangle or a square or a parallelogram. I mean, that's not too bad. I've narrowed it down to 3. If it's a square, that means every length would have to be the same. Is that true? I mean, parallelogram would probably do it. I think that's where you get the mark. I'm actually going to check that. I'm pretty sure because like a square and rectangle and square they're just like subsets of a parallelogram because they are parallelograms, aren't they? So I think the answer here is parallelogram, and I'm going to just check that. I don't think you have to go into more detail than it's a yeah, it's parallelogram. Yeah, because rectangles and squares are parallelograms by definition. Yes, a parallelogram is the one I'm doing. Yeah, cool. As I said, I'm hanging around here, so if anyone else, it doesn't have to be just Rashida. I'm always grateful. Anyone's got a question, please ask. I said before, if anyone's out there, anyone needs any help, let me know. I'm gonna hang around here for about another 10 minutes. Excuse me, there's a sorry, can't speak English. Alright, so let's do register one way. We go. Right, let's see if anyone's asked anything. Nope. Okay, I think that'll be about that. If anyone needs any help, let me know. I'm also on Microsoft Teams right now, so if anyone needs something, just pop on Microsoft Teams. I'll just pop back on YouTube. It's not a problem. Take care, my dudes. Look after yourselves. Bye.